Good morning. Today we're going to talk about ellipses. So an ellipse is basically what we used to just call an oval. So it would look like that, or it could look like that. And here's an application of it, even though you really can't see the elliptically shaped reflector. This is going through this guy's arm and showing up in his kidney, which looks like it's in its shoulder, but it's not. All right, so let's talk about what an ellipse looks like in the different parts of the ellipse, okay? So an ellipse, of course, looks like an oval, all right? Of course, the center is still in the center. The big terms that we need to know about are the major axis. The major axis obviously is going to be the longest one, and then the minor axis is going to be the shorter axis, okay? And then you've got another term called the vertices, which is a little different than when we were talking about like the vertices of a triangle or something like that. So a vertex is where the ellipse will intersect with the different axes, okay? And then, all right, so let's go and talk about the equation of an ellipse and compare it to different part now. Semi-minor axis is half of the minor axis, okay? And then semi-major axis is half of the major axis. So whenever you hear me say that. All right, now let's go and compare it to a circle. All right, so you've got a circle equation. Remember, in standard form, it's x squared plus y squared equals r squared. And then if you translate it anywhere away from the origin, it's going to be x minus h squared plus y minus k squared, and that's going to equal r squared. All right, so now let's go on down to look at an ellipse equation. An ellipse is going to look very similar, except now remember, it's not going to be circular, it's going to be stretched either horizontally or vertically like this. So I'm going to show you the two different things that can happen. All right, so you've got, for an ellipse, you've got x squared. I'm just going to do it if it's centered at the origin, over a squared, all right, plus y squared over b squared, and that equals 1. All right, now here's the deal. If it's stretching horizontally, this number a is greater than b. All right, if it's stretching vertically and your major axis is going along the y-axis, then b is going to be greater than a. A textbook might write it out a little bit differently, but that's the way I usually look at it. I can show you what the textbook would do for you. There it is right there. It will just write it out. It'll put the a first all the time. And that just confuses me, okay? So, and it confuses a lot of people because they don't understand that really the major axis is just going to be the bigger axis. So if you just think like that, it's all good. Okay, so where was I? Okay, let me go move this down a little bit here. All right, so that was when it's centered at the origin. But let's say you want to translate it. You're going to do exactly like you would have in a circle. And then you're just going to have a squared. And then you've got y minus k all squared all over b squared, and that still equals 1. So your center is still going to be at h and k. Just like you did when you had it in a circle here, the center was at h and k, and then your radius was r, okay? So this side always has to equal 1, so that's going to be the challenge for some of the things that we're going to be doing, all right? So let's play around with some of these. Here you go. I need to make this a little bigger. I'm not sure what's going on with this. Hold on. Okay, I can't get my screen to go any smaller, so you're going to have to see my toolbar up at the top here. Okay, so here you go. Standard form of an ellipse to graph and name the critical points. So we've got x squared plus y, or x squared over 16 plus y squared over 9 is equal to 1. All right, so our major axis is going to be along the x-axis. 16 is greater than 9, and that is underneath the x, so that's how we figure that out. All right, and so the half of the major axis, the semi-major axis, is going to be the square root of 16. So we're going to say A is equal to 4, and B is equal to 3. All right, and since there is nothing here, that's no H and K, those are going to be centered at 0, 0. So let's go down, and what you do is you count from the center. So here's the center, 0, 0, and you're going to go 4 along the x-axis in either direction. 1, 2, 3, 4. And then you're going to go 4 in the other direction. And then your minor axis is your B. All right, you're going to go, so up your semi-minor axis here goes up 3 and then down 3. So it looks almost like a circle, but kind of squashed just a little tiny bit. And that's really all you do. All right, let's try another one. All right, so this one's a little different. All right, so again, you're going to take the square root. So technically this is called B. B is always your minor axis. So B is equal to 2, because this is B squared. 4 is B squared. A is equal to 5. But then you just think, which way am I going? I'm going to go up and down 2 along the, or left and right 2 along the x-axis. And again, it's centered at 0. So this one looks like this from the center, right? Count 2, count 2. Then we go along the y-axis, we go plus or minus 5. Okay, so we're going to go up and down 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5. And that is all you do with that. And then you try to draw it kind of in a curve. Okay, let me see if I can find a translation on here. That's the textbook version of that if you want to read that. We're going to talk about C later. All right, that's going to be something called the focus. All right, so we'll talk about that on another day. We're not going to worry about that right now. So let's talk about looking at this one right here. You've got y minus 3 squared over 25. Okay, you can read it. All right, so first of all, go ahead and let's find the center. All right, the center is going to be at 3, negative 4. That's your center. It's not C, it's your center. So I'm going to go and graph 3, negative 4 right here. And then really all you do is go and say, well, my major axis goes along the y. So A is equal to 5. Or you could say plus or minus 5. And B is plus or minus 3. All right, so we're going to go along the y-axis up 5. And we're going to go down 5, 2, 3, 4, 5. I think I did that right. And then along the x-axis, we're going to go 3 in each direction. And there you go. Oops, it's a little bit fat right there. All right, and that's really what your ellipse is going to look like, and you can connect your little tick marks there. All right, so then you can go and you can label the vertices. We're going to worry about the foci tomorrow. All right, so you can label your vertices, and eventually you're going to see a pattern because there's a mathematical formula for that, okay? So one of your vertices is going to be at 3, 1. Another one will be at, what is that? 1, 2, 3, 4, 5, 6. All right, 6 and negative 5. All right. Nope, 6 and negative 4. I might have counted that wrong. No, I didn't. Let me make sure I counted that right. 1, 2, 3, 4, 5, 6. Yep, 6 and negative 4. Another one is going to be at 3 and 4, 5, 6, 7, 8. 3 and negative 8. And then the one here on the axis is going to be at 0, negative 4. All right, so those are your vertices. Okay, so for your assignment, I want you to practice 3 of these. All right, we're going to do those tomorrow. So let me get to, ooh, there's your answers. I want you to do page 638. There's your answers for number 16 if you want to see it. Number 16, number 17, and number 18. All right, have a great day.